Java cryptography is crucial for enterprise app development. It provides tools and APIs for secure communication and data protection. With rising cyber threats, safeguarding sensitive data is paramount. Java cryptography offers robust mechanisms to achieve this, ensuring data confidentiality, integrity, and authenticity. JCA is the foundation of Java cryptography. It provides a framework for accessing and using cryptographic services. JCA defines a standard interface for various cryptographic primitives. These include digital signatures, message digests, and encryption algorithms. JCA allows developers to integrate security features into Java applications seamlessly. JCA's provider-based architecture enables flexibility. Developers can choose from different cryptography providers. The architecture ensures interoperability between different implementations. This allows developers to switch providers without modifying application code. JCE extends JCA by providing implementations for encryption algorithms. It includes ciphers like AES and DS for data encryption. JCE also supports key exchange algorithms like Diffie-Hellman. These algorithms enable secure communication over insecure networks. JCE is subject to export control regulations due to its cryptographic strength. The standard Java runtime environment includes a limited version of JCE. Unlimited strength JCE requires downloading and installing additional policy files. This ensures compliance with export regulations while providing full cryptographic capabilities. JKS is a key management system in Java. It provides a secure repository for storing cryptographic keys and certificates. JKS files are password protected, safeguarding sensitive key material. The system supports various key entry types, including private keys, public keys, and certificates. JKS is essential for managing digital identities in Java applications. It enables secure storage and retrieval of keys used for encryption, decryption, and digital signatures. JKS facilitates key sharing among different applications or components within an enterprise. JESI provides a framework for secure socket communication in Java. It enables developers to build applications that communicate over SSL/TLS, supporting various protocols including SSL-v3, TLS-v1, 2, and TLS-v1, 3. These protocols ensure secure data transmission over networks. JESI handles key exchange, encryption, and authentication during secure communication. It leverages JKS for managing keys and certificates. Crucially, JESI is essential for securing web applications, web services, and other network-based applications. Java cryptography plays a vital role in various enterprise applications. One prominent use case is data encryption. Sensitive information like customer data, financial records, and proprietary algorithms are encrypted using JCE algorithms. This protects data from unauthorized access, both in transit and at rest. Another critical application is secure communication. Enterprise applications often communicate over networks, exchanging sensitive data. JSE ensures secure communication channels, protecting data from eavesdropping and tampering. This is essential for applications like online banking, e-commerce, and secure messaging. Getting started with Java cryptography involves understanding the basic concepts and APIs. First, familiarize yourself with JCA and its provider architecture. Explore the different cryptographic services available, such as encryption, digital signatures, and message digests. Next, delve into JCE and its implementation of encryption algorithms. Learn about symmetric and asymmetric encryption, key exchange mechanisms, and different cipher modes. Start with simple examples, such as encrypting and decrypting a string using a symmetric key algorithm like AES. Let's illustrate Java cryptography with a simple example, encrypting a file. We'll use AES, a widely used symmetric encryption algorithm. First, generate a secret key using the class. Then, create an object, specifying AES in GCM mode for authenticated encryption. / generate a secret key generator keygen = key generator, get instance AES, secret key keygen generate key, / create a cipher object, cipher = cipher, get instance AES GCM no padding. Next, initialize the cipher for encryption using the generated secret key. Read the file to be encrypted, encrypt the data using the cipher, and write the encrypted data to a new file. / initialize the cipher for encryption cipher. Init cipher encrypt mode secret key. / read the file to be encrypted byte file data equals sign files. Read all bytes paths.get path to file txt. / encrypt the file data byte encrypted data equals sign cipher do final file data. / write the encrypted data to a new file files write paths.get path to encrypted file nc encrypted data. This example demonstrates the basic steps involved in encrypting a file using Java cryptography. Remember to handle keys securely and choose appropriate algorithms and modes based on your security requirements. When using Java cryptography, follow best practices to ensure robust security. Use strong keys and algorithms. Choose key lengths that provide adequate security against brute force attacks. Select algorithms that are well vetted and proven to be secure. Protect keys securely. Store keys in a secure key store like JKS, ensuring proper access control. Never hard-code keys directly in your code, as this exposes them to security risks. Use appropriate key management techniques to protect keys throughout their lifecycle. Java cryptography provides essential tools for securing enterprise applications. From data encryption to secure communication, it offers a comprehensive set of APIs and mechanisms to protect sensitive information. Understanding JCA, JCE, JKS, and JSE empowers developers to build secure and reliable enterprise applications. In today's digital landscape, cryptography is no longer optional. It's a necessity for maintaining data security and integrity. By leveraging Java cryptography effectively, enterprises can safeguard their data, protect user privacy, and maintain trust in their applications.